Alright, in this screencast we're going to look at how we analyze graphs of functions. And the first thing we're going to look at is figuring out the domain and different values just by looking at the graph. So we've got a function f right here, and it says to find the domain of f. So you can notice we read graphs from left to right. You notice that it includes this point here at x equal -1. So we're going to use a square bracket right here. And then it goes all the way up to x equals 5, but it doesn't include 5, so we have a parentheses right there. So the domain of f is from -1 to 5. Or you could say -1 less than or equal to x less than 5. Let's look for the function values of f of -1 and f of 2. Okay, well, you just read it right off the graph. So f of -1 is 1. F of 2 is down here, and it is -3. The range of f is all the y values that are included in your graph. So notice that the lowest y value is -3, and the highest y value is 3. So we say that the range is from -3 to 3 inclusive. For a graph to represent a function, it must pass a vertical line test, which means that any vertical line that we run across the graph can only intersect the graph in one point. So you notice that right here, this vertical line hits it in 2 spots. So it is not a function. Now, if I run a vertical line anywhere on this graph, it will only intersect the graph in 1 spot. So it is. Same thing here. Vertical line intersects it at no more than 1 spot. So yes, it is a function. And the same thing here, even here, because you'll notice that right here there's a hole. So even if I drew a vertical line right there, it only intersected at one point, which would be right there. So this is a function. Okay, it's really useful to find the zeros of a function because those are places where the function crosses the x-axis. And the zeros are defined right here. The zeros of a function f of x are the x values for which f of x equals 0. So if we want to find the zeros of this function, we're going to set the function equal to 0, and we're going to solve for x, which means we're going to factor this. And we want to get a positive 1 in the middle, so I think I'm going to do a +2 and a -5. That'll give me a 6x minus 5x, which is 1x. Okay, now once we've got it factored, we set each factor equal to 0. And I get x is equal to 5/3. And over here, x plus 2 equals 0. So x equals -2. So we have two zeros, 5/3 and -2. So to find the zeros of a function, you set the function equal to 0 and solve for x. Let's do it for this rational function, okay? Now, remember that for a fraction to equal 0, we only need to make the numerator equal 0. So I'm just going to set the numerator equal to 0. And I get 3 equals 2t. 3/2 equals t. Now you need to make sure that your answer is in the domain. And the domain for this rational function is x cannot equal, come here, there we go, x cannot equal -5. Well, that's in the domain, so we're safe. So there's your 0 for that function. It's also helpful for us to figure out where a function is increasing or decreasing. So these are mathematical definitions, and they're complicated. Basically, as you read a graph from left to right, if the graph is going up, it's increasing, and if the graph is going down as you go from left to right, the graph is decreasing. If the graph is perfectly flat, it's constant. Okay? So let's check out and get some intervals on here. Now, believe it or not, right there, it is neither increasing or decreasing at 0. So we're going to say that it is increasing from -infinity to 0 and then from 0 to infinity. Okay, this one right here, it's increasing from negative infinity to negative 1. And it's also increasing from 1 to infinity. It's decreasing from negative 1 to 1. Notice that I'm only writing x values because these are intervals. These are not points, okay? So when we're talking about increasing and decreasing intervals, we use x values. Okay, this one right here. It's increasing from negative infinity to 0. And that's the only place it's increasing, isn't it? Because it is constant from 0 to 2. And then it is decreasing from 2 to infinity. Other useful information from graphs are relative minimums and relative maximums. Okay, so we say that a value f of a is called a relative minimum if there exists on an interval from x1 to x2 a value a such that x1 is less than x2, and that implies that f of a is less than or equal to f of x. In other words, f of a is the lowest y value of any y value on that interval. And then the relative maximum means that f of a is the largest y value of any y value on that interval. Okay? So, fortunately, graphing calculators are very useful tools for finding maximums and minimums. So I've put the function into y equals here, 2x cubed plus 3x squared minus 12x. I better change that, right? Okay, I fixed it. And I'm going to show you my window real quick. Let me drag that down there. So x is going from negative 5 to 5, y is going from negative 10 to 20, and there's our graph. So it looks like the relative maximum is right there, and the relative minimum is right there. So I'm going to go to Second, Calc, which is up above the Trace button. And I'm going to choose number 4, which is maximum. And for my left bound, let's see, this is negative 1, 2, 3, 4. I'm going to put negative 3.5, hit enter. And for my right bound, I'm going to put negative 1, hit enter. And for the guess, I'll just hit enter again. And there's the maximum. Looks like it is at x equals negative 2, y equals 20. So my relative maximum is 20. Okay, now let's get a relative min. So I go Second, Calc again. This time I choose number 3. And for my left bound, I'll use 0. And for my right bound, I'll use 3. Enter. I'll just hit guess. And there's our relative min at negative 7. A very common function is a linear function. And so if we have a linear function named f in terms of x, it's always going to be in the form of f of x equals mx plus b, where m is the slope and b is the y-intercept. So let's figure out how we can get a linear function from 2 points. So if I know that f of 1 is 3 and f of 4 is 0, that means the slope is going to be my change in y over my change in x. So I'm going to get 3 over negative 3, which is negative 1. Okay, so that means that I have f of x equals negative x plus b. And I can plug either one of these points in for x to get b and f of x. So let's use this point right here. So this says that when x is 4, f of x is 0. That means b is 4. So now we know our linear function for these 2 points. F of x is negative x plus 4. And the last function we want to look at is something called the greatest integer function. And what it says is f of x is the greatest integer of x that is less than or equal to x. So for example, if I do the greatest integer of 1.3, Well, we round down to the greatest integer, which would be 1. Okay, how about the greatest integer of 0.7? That would round down to 0 because 0 is the greatest integer that's less than or equal to 0.7. Negative numbers are kind of tricky. Okay, how about negative 2.4? Okay, you have to think of a number line. What's the greatest integer to the left of negative 2.4? And that would be negative 3. Okay, now when you graph these, you get something that looks like a staircase. So it's sometimes called a step function. So all these numbers between 0 and up to but not including 1 round down to 0. As soon as you get to a number that's 1 or greater but less than 2, it rounds down to 1, and so on and so on. Notice you have open circles on the right, and you have closed circles on the left of each step. The domain is all real numbers. The range is all integers. There are no decimals in the range. The graph has a y-intercept at 0, 0, and x-intercepts in the interval from 0 to 1, including 0. The graph is constant, which means it's perfectly horizontal between each pair of consecutive integers. And then you jump each time one integer. Okay, so to graph this on your calculator, you just go in y equals, and then you go to math, over to numerical, and it's number 5. So if you do the greatest integer of x, and then in your mode, make sure you're in dot mode, because we don't want to connect those steps. So I arrow over to dot, hit enter, and then I hit zoom 6, and there's your step function on your calculator. Alright, so that's a brief introduction to analyzing graphs of functions.